you can start.
Doctor, can you hear my voice?
Yes.
Okay.
We start?
Yes, you can start.
Okay, so our project is about sustainable retrofitting methods in old Beirut building for energy conservation purposes. Okay, so the objective of our project is developing a 3D simulation model of a typical old Beiruti house on eQuest. We assessed the energy consumption due to cooling if the house was to be fully conditioned by mechanical cooling system, which is the base case scenario. And then we tested different retrofitted scenarios to reduce the energy consumption of the cooling system mounted in the residence. And finally, we compared the results, choose the most effective method in terms of energy saving, capital cost, and payback period. So starting, we know that Beirut has many historical buildings, and they are a consequence of a flow of different civilizations. Their aesthetic and construction uniqueness is influenced by Italian, French, and Ottoman styles. In Beirut, approximately 30% of the buildings were built before 1950s. The construction were extremely focused on providing thermal comfort by means of natural ventilation and cooling practices. Many countries encourage the preservation of such buildings. Many research studied and focused on old construction practices in Beirut. Some took into consideration the window-to-wall ratio and found it about 40%. Starting from 1930, building construction were based on a...
Ran,
Yes.
Can you please try to change your location because the voice is not very clear?
Okay. What about now?
Yes, better.
Okay. In the 1930s, building construction were based on a mixture of stone and concrete material. By the start of the 21st century, the mixed structures appeared due to the usage of concrete cement introduced by the French architecture. Concrete replaced stone and steel beams appeared to support the imported French red tile roofs. Traditional buildings, as we can see in Beirut, have their walls painted with bright color to reflect solar radiation. In 2005, building law encouraged double glazing for windows. The past year witnessed an industrial development which caused a dramatic increase in the amount of greenhouse gas effect in the atmosphere. As we know, greenhouse gas are the primary contributor to global warming, causing substantial changes in Earth temperature. The climatic change has prolonged the summer period and increased both the heat waves frequencies and the urban heat island. And the old buildings were no longer able to provide thermal comfort using only natural cooling and ventilation strategies. And by the end of the century, Beirut is expected to have 50 to 60 more days with temperature exceeding 35 degrees centigrade, and precipitation will decrease by 120 millimeters.
Based on what Ren said, it is primordial to calculate the cooling load of the buildings. So the most known method for calculating the building load is the heat transfer method. This method is based on the finite volume approach. It consists in discretizing the walls into finite control volumes and apply the heat balance equation on each of them. But for simplification, the heat flux is sometimes assumed to be unidirectional along the thickness of the wall in order to get a 2D element. The method accounts for the long-wave radiation heat exchange between the sky and the outer face of the wall, as well as the radiation heat exchange with the ground. In addition, a short-wave heat exchange takes place between the wall and the sun rays. In addition, a convection takes place due to the speed of the air which is in contact with the outer face of the wall. At last, the heat is also conducted through the wall material by conduction. The same heat exchange processes takes place for the glass, except for the short-wave heat exchange, since the window is reflecting the light and the percentage absorbed is neglected. But as I'm saying, we are supposed to make a lot of assumptions in order to solve the system. And all these assumptions are prone to create errors in the output solution. So for higher precision, we should take into consideration view factors between the wall that should be taken into consideration to account for the long wave radiation heat exchange between the walls. However, the calculation of these factors requires powerful computer performances and are time consuming. Next slide. An alternative for the heat balance method that is less time consuming and shows high accuracy is the transfer function method. This method is based on the response factor principle. This principle, I will explain it by an example. The idea is that for a specific room, a 1000 BTU per hour heat gain through the exterior wall will cause the same response over a period of hour as a 2000 BTU per hour heat gain, for example. So the load will change, but the heat gain to load conversion will remain the same. This principle is based on three other principles. The principle of superposition, which states that the total room load is equal to the sum of the loads calculated separately for each heat gain component. The second principle, which is the principle of linearity, it states that the magnitude of the thermal response to a heat gain varies linearly with the size of the heat gain. The third one, the principle of invariability, it states that two heat gains of equal size occurring at different times will produce the same thermal response in a room, as I gave the example of 1000 and 2000 BTU per hour heat gain. Next slide. Okay. All the previously mentioned principle resume to the use of the following equation, the transfer function equation. In this equation, capital Q represents a load. Small q represent a heat gain. Small omega and small v are the transfer function coefficient. And the subscripts refer to specific point in time. For example, subscript 0 is the current hour. 1 is the previous hour. 2 is the 2 hours previous. And small q represent the heat gain. Values of this coefficient, small omega and small v, varies for each type of heat gain and each type of room due to different heat transfer processes. And we got them from tables published in ASHRAE for different heat gain component, room type, building weights. So this method allows for easier calculation of the room load since it consists into 4 easy steps. First, the user has to determine the hourly heat gain. Then find the transfer coefficient from ASHRAE, as I said, small v and small w, and plug them into the room transfer function equation, and finally get the room load.
So in order to assess the energy performance of an old Beiruti house, a typical residence was investigated and modeled on eQuest that used the heat transfer function method. This is the 3D of the house. Okay, so the house is oriented towards the east. It is formed of a salon and a dining room, a kitchen and a sitting room, a master bedroom, a guest bedroom, a corridor, and 2 bathrooms. It is 92.6% conditioned, and it has a total area of 1,214 feet square. The exterior facade has 8 windows, single clear type, 125-inch thickness with no fins or overhang. The house has 2 doors, one on the east facade, which is the entrance, and one sliding atrium. The walls were all made of heavyweight concrete without insulation with an absorbance of 0.6. The wall and the floor were made with 6-inch concrete, while the ceiling is made with 8-inch concrete. The cooling and heating equipment was the DX coil, and the HVAC system is a split system single zone. As for the occupancy, we thought of a family of 5 persons, 2 parents and 3 kids. During weekdays, parents or the dad and the kids go to school or to work, and we suppose that only 1 person is at the house. During weekends, the occupancy increased. Weather data for Beirut were collected and were used as an input on eQuest. and the electricity bills were plugged as blocks.
So after using the inputs that Ran talked about for the house geometry, the material composition, as well as the weather data and occupancy schedule in eQuest, monthly simulations are performed in order to obtain the monthly electric consumption and utility bill for the base case scenario. That means we do not change nothing in the envelope of the house. And after that, we take many alternatives and assess them in order to reduce the electrical consumption of the considered old residence. The base case described before is studied, and the results are shown here. The first figure shows the total monthly electric consumption. And it shows that the electric consumption of lighting, which is in yellow, and electrical equipment in green remains constant throughout the year, since they are not affected by outdoor weather conditions. Note that the electric load associated to ventilation fans is not related to the ventilation load. It is only related to the size of the fans. And since we are supplying a constant amount of fresh air for ventilation throughout the year, this load is assumed to be constant. Whereas the electric consumption for cooling purposes is observed to be varying throughout the year. It is in blue, it is more pronounced during summer months and it reduces during winter months. So according to the weather conditions of Beirut, residents in Beirut requires more cooling than heating, especially during summer months. That's why the heating load, which is in red, is less than the cooling load, which is in blue. And this is what makes electricity consumption more pronounced during summer months. As for the heating electricity consumption, for the water heating in orange, is the energy used to heat the water for personal use, for example, to take a bath. It is then obvious to see high values during winter and low values during summer months. In the second figure, we calculated the monthly electric bill for the base case. The annual bill for this base case is found to be around $3,000. The highest values are observed during summer months, during which, as we said, the cooling loads are highly pronounced. Consequently, the cooling load constitutes the highest proportion of energy consumption in Beiruti old construction house. So based on this result, and in order to offset the energy bill of an old house, we need to reduce the cooling load, since it constitutes the highest proportion of the house's energy consumption. For this aim, this work assesses 4 sustainable retrofitting methods that are assumed to decrease the cooling load. Ben? Okay. In addition, this figure stresses more on how much the cooling load are pronounced throughout the year compared to other loads. So, so in this alternative, it's the first alternative. We propose to insulate all the exterior walls of the residence in order to decrease the heat gained or lost through the walls layers by conduction. Once this heat transfer path is decreased, the power needed from the cooling system to decrease the room temperature, or not even to decrease, to get the room temperature to required levels for thermal load removal is reduced. This alternative has been used in many research studies and shows to be efficient in many applications. So in this work, we will use polyurethane of 3-inch thickness as an insulating material. The first figure compares the annual energy consumption of the base case to that of alternative 1, which is this alternative. And it shows that adding insulation to all of the exterior walls have led to a noticeable decrease in the electric consumption. The electric load related to lighting, electrical equipment, water heating have not been affected by the external insulation. In fact, these are considered internal heat sources, while the external insulation attenuates external heat gains. The load related to cooling, heating, and ventilation showed a considerable decrease due to the addition of outside insulation. As a matter of fact, when external insulation is used, the heat transfer from the exterior to the interior of the house is reduced. Consequently, the load needed to bring the temperature of the inside air to required levels is reduced. In conclusion, this alternative showed a approximately 6% decrease in annual energy consumption compared to the base case. Here we can observe that the capital cost is high and the payback period is long. The high capital cost is associated with the fact that all the walls are insulated, which means a high area of insulating materials need to be purchased, which elevates the initial cost and elongates the payback period. Based on that, we suggest insulating a smaller surface area of the house. For example, instead of insulating all the walls of the house, we propose to insulate the roof. The material used for the insulation is polyurethane R36, having a thickness of 6 inches, and this has the same working principle as the alternative before. However, we are using a smaller area to decrease the capital cost and payback period. So here, the first figure shows that adding insulation to the roof have led to a noticeable decrease in the overall annual energy consumption as compared to the consumption obtained in the base case. The electric load related to lighting, electrical equipment, water heating, as I stated before, have not been affected by the roof insulation, since they are considered internal heat gains. The load related to cooling, heating, and ventilation showed a considerable decrease due to the addition of the roof insulation. This decrease is higher than the decrease obtained when insulating all the exterior walls, because the main contributor to the increase in heat gains is the solar heat gain. And the solar rays are incident perpendicularly to the roof, whereas they have a certain incident angle at the wall surface. So in conclusion, the effect of solar rays is more pronounced at the roof than at the walls. In conclusion, the electric consumption shows a decrease by 7% when using this alternative compared to the base case. So as we predicted, the capital cost as well as the payback period decreased when insulating a lower area, which shows to be more beneficial and cost-wise and efficiency-wise.
The third alternative proposed was changing window types. We used double reflective glass of 0.25 inch glass and 0.25 inch air gap. Many studies suggested the use of double glazing in an attempt to reduce the energy consumption. The research demonstrated that the use of double glazing window in a low mass room reduced the cumulative energy consumption by 11%. In fact, the air layer present between the window will decrease the air temperature from the outer glass to the inner glass, and thus decrease the heat gained by the room, and thus lower the electric power that will be needed for cooling. In addition, the use of reflective material increases the portion of solar waves reflected, and thus the absorbed and transmitted wave will be reduced. Okay, so we can see in the first picture that the area lighting and the equipment did not change, and the water heating, because they are not affected by changing the glass type. The space heating increased since in winter it is beneficial to allow heat to transfer from outside to inside, especially that Beirut weather is moderate. And we can see that the space cooling decreased. Using this alternative, we can see that the electric consumption was reduced by around 4%. However, the high reflective glass is expensive. It has a high capital cost. That's why we see that this alternative has the highest payback period of 9 years. And finally, in an attempt to reduce the capital cost, we thought of changing the lighting density and using LED bulbs in all houses. Research has proposed this alternative, and they observed a reduction of electrical bills, CO2 emission, and greenhouse gases. This alternative is practical since all buildings always use incandescent lamps that are energy exhaustive. We can see here, as expected, that the area lighting was reduced, the space cooling was reduced, but the space heating increased because, as we said, the incandescent lamp give more heat. And in this method, we found that the electric consumption was reduced by around 15%. In terms of capital cost and energy saving, this alternative seems to be the best because we can see that almost it doesn't have any capital cost. The LED bulbs are very cheap to buy.
So in order to choose the best alternative to offset the energy consumption associated with cooling demands in all the Beiruti buildings, the four previously assessed alternatives are compared for their annual electric energy consumption, cumulative net savings, and payback period. The graph shows that all the alternatives have peak values during the summer months, since these months require the higher cooling load. First alternative is decreasing the lighting density, which shows the lowest energy consumption throughout the year compared to the other alternative. Second, the roof insulation alternative shows amazing capabilities of reducing conducted direct solar heat gains through the roof. After that, the insulation of the exterior walls showed energy consumptions slightly higher or equal to the roof insulation alternative, and no considerable heat gains were depicted through the walls. At last, changing the window types. It shows no considerable saving in electrical consumption as compared to the base case. And this may be attributed to the solar behavior of the orientation of the windows.
I'm having a trouble.
Okay. This figure shows the cumulative net savings and payback period for all the assessed alternations. Retrofitting exterior insulation for all the exterior walls has the same capital cost as the change of windows type, which is huge. On the other hand, both the roof insulation and the change in lamp bulb type have low capital costs, with a capital cost approaching zero for alternative 4. Based on these observations, changing the lamp's type or insulating the roof level in all Beiruti buildings was deducted to be the simplest, less expensive, and most energy-saving method. Thank you for your time and your attention.
Thank you.
Okay, thank you for the presentation. First, anyone wants to ask questions before I start? Okay, so it's a nice work. First, I want to ask you about the economical analysis. When you performed the economical analysis, what were the parameters that you considered?
What do you mean by parameters?
Yani, for example, the initial cost, the discount rate, the operational cost.
In eQuest, you just mentioned the material you are using and the area, and the surface area that you are using of this material, and it computes the capital cost. You just have to insert the bill, the electricity bill in the country.
So the economical,
the
economical analysis was also performed in eQuest?
Yes, it has built-in numbers.
Okay. Tab, do you know, did you have an idea about the parameters he considers, the initial cost he takes, the benefits he considers, or it all is lumped in and you don't have all of, just you get the final net present value?
Yes, we just
have access to the directory.
So you don't know,
material and
you don't know if eQuest consider time risks, because with time value of money will change. So does eQuest consider this or not?
Do you mean with time, the change with time?
Yani value of money, yani for example, if you want to invest in Lebanon, it's not like if you want to invest in United States, because in United States, the stability of the country is much better. So you can expect that the value of your money will not lose a lot with time. Okay. While, for example, in Lebanon, each day your money, the value of your money is losing a part of it. This is why we say, with time, it depends on the country we are investing in. We consider a certain factor called the discount rate that will allow us to know if the country is safe or not.
Maybe in a more advanced software, this will be available.
Yani you didn't input any parameter for the economical analysis. Everything was done.
We just input. No, we just input the watt,
Material.
the material,
price per
step. Okay.
and the
Yeah.
price per watt in Lebanon.
The cost
We
of
added this. The cost of
Equest
1 watt
is a
in
free
Lebanon.
software available. I think maybe more sophisticated software would give this opportunity to add this discount.
Can you go a little bit to the graph of NPV, please?
Which one? I didn't hear.
Any graph. There is one graph representing 4 alternatives, comparing
Yes.
the 4 alternatives.
Yes.
This one?
No, in terms of economical study. So the last slide, yes, this one. Can you explain why for alternative 4, I'm starting from 0, while for the other strategies I start from a negative value?
Okay.
Because when you pay, you're losing. So, for example, when you bought the insulation for the roof, for example, you lost money, and so you have a payback period where the graph touches the 0. So, for example, for window type, you need 9 years to regain the money. I think Equest considered that the price of the LED bulbs is so low, so that it almost doesn't have a capital cost.
Or maybe it considers that it's already implemented, maybe in the lighting is already implemented. So
No, we changed it.
We changed the
while
lighting
doing this
density.
alternative,
you change it,
we
but,
changed the
but the cost is very small, so that it's nearly 0.
Yeah, I think
Yes.
I think that's why he took it 0.
اوكي بس even الا ما يكون في some cost يعني يمكن هي اصغر من 0
Maybe
بس
it's not 0,
ممكن
but
negligible
compared to
with respect to other
$400.
alternatives.
okay fine يعني from this graph you suggest to use alternative 4.
Yes,
Yes, as we
because
say in the conclusion.
Okay, so what about if you want concerning this is about the economical study concerning the amount of kilowatts saved. Also, it was the highest, the one you saved the more with. Can you go back?
we thought of both way.
In slide 26, we showed that.
Okay. Okay, so here
For the lighting density, which is in gray.
Okay.
Okay, so in order to choose which alternative is better, we need to combine their savings in kilowatt and their initial cost and payback period together.
Okay, so all of this is taken into account بالeconomic analysis, which will be the final, يعني this will give you the final decision.
Yes, combining all the results as for savings, as for capital cost, payback period, we choose this one.
Exactly.
We thought that this is a building that is already built in Beirut. It is old. We want to make some slight changes, so we considered both.
Okay. Okay, great. Okay, thank you. Thank you for your time.
Thank you.
Thank you, Doctor.
Welcome. Does anyone have a question before we start?
Doctor, concerning the exam.
Yes.
We need to know some historical reviews as you gave in the course.
Can you please repeat?
And we need to memorize things.
I didn't hear well. Can you please repeat?
Okay, for the exam, we need to memorize the information you gave during the course.
You don't have to memorize details. No, You just have to understand overall concepts. And if you read several times the slides, it's enough. No need to memorize anything. As I told you, you can prepare a formula sheet to bring with you to put all formulas on it. And concerning information, you don't have to memorize, you should understand concepts. So, for example, what is conduction? What is convection? What were the main innovations? And you should know what is water wheels, what is turbines. In general, I will not ask you, for example, in which year was invented the turbine. No, of course.
Okay, deal.
So information that just you can understand it from reading the slides several times. No need to memorize anything.
Okay, thank you, doctor.
Welcome. Any other question?
Hello, Professor.
Hello.
How are you?
Yes, Jamil.
Yeah, I was solving أنا من last week I wanted to ask you a question بخصوص
Yes.
chapter 3 the problems.
Yes.
في كان turbine بالproblems we used نحنا P قصدي specific volume times difference بالpressure to get the work.
Okay,
كنا عم
look.
نحل شيء
Yes,
first
هيدي
yeah.
للpump. This is for the pump. Okay.
Yes, للpump.
Look.
كان في alternative solution نحن نحلها using H يعني هي HI minus HE
Yes,
بس نحن عوضنا HI.
Okay. بس هي المشكلة look when you have the pump if you are able to get H1 and H2 so then you can do it as WP as H1 minus H2 H2 minus H1 okay now in case
Okay.
sometimes لأنه البوينت 2 بيكون بالsaturated liquid region okay وبالtables not all values you need are present. This is why a second approach to get WP is to get V, which is specific volume in meter cube per kilogram times delta P. So you can write in another way that WP is V times delta P. What is the value you take for V? Since you consider that it's a liquid, so you neglect to change in specific volume. And you can take the value of V, which is the value of V at point 1, يعني at the inlet of the pump. Okay? So at point 1, when the fluid will enter at the pump, you are in the saturated liquid just على saturated line, صح؟ يعني you are على point F if you want. We call it point F. So this is saturated liquid who will intersect, this point separate the liquid zone from the mixed zone. Okay? So this point, how you get its characteristic, you go to بيكون معك the pressure at the inlet of the pump. You go to the to the tables, بتروح على pressure entry. You take at this pressure what is specific volume at point 1, V1, and you multiply V1 by delta P to get WP. So we use this approach when you are the tables cannot give you H2. يعني ساعتها this approach will help you to get H2 because H2 will be then H1 plus V delta P.
Yes. بس professor بالproblem كان فينا نجيب H1 and H2 but we solved it by using the specific volume. أنا جت حليتها by using H1 and H2.
جربها you should have same values. طلعوا different?
No, ما كان the same values.
بس
different 500 watts كان.
500 قد ايه؟
watts.
500 watts. ما هي أصلا الفاليو هي in when you get it in kilojoule per kilogram. مش in watts. أنت رجعت ضربتها يعني to get it
هو
in watts.
في rate of work. rate of work مش الwork.
rate of work. Look مبدئيا it should not vary as much. Okay. بركي في error of calculation. You can send me your work to check it. بس مبدئيا it should not vary in this amount. No. مفروض تطلع close values. Okay.
Okay تمام. Thank you.
So look, to be on the safe side, use V delta P. V delta P is a safe method لأنه you are in the liquid zone, you can neglect variation of V.
Okay great. وبخصوص نحن على طول بالبامب وبالتوربين على طول S is constant. inlet أو outlet.
صح. لأنه we
great.
assume isentropic processes.
Yes.
Yes. Other questions? Okay, guys, good luck for the exam. If you have any other question, feel free to send me a WhatsApp whenever you want, okay?
Thank you, Professor.
Yalla, see you on Wednesday at the university.
Okay, thank you, Doctor.
Welcome. Welcome, Amir.
يعطيك العافية.
Bye-bye.